So question 7 is you have a radioactive source, polonium, that decays into lead and a helium nucleus, which is also known as an alpha particle. So this nucleus has a charge of plus 2. It doesn't have the electrons around it, and this is your alpha particle, which has been thrown out of this polonium nucleus. Now, the first part of the question is complete the nuclear equation. So we've got 84 protons in polonium, and 2 protons are associated with the alpha particle. So 82 protons are remaining. The sum of these two values should equal 84, and the sum of the top two values should equal 210. So we got 206 protons and neutrons in lead, plus the 4 total protons and neutrons in the alpha particle, give you a total of 210. So the right hand side should equal the left hand side. So why contamination of the inside? Explain why contamination of the inside of the human body by radioactive material that emits alpha radiation is highly dangerous. So if you have an alpha source inside the body, the reason why it's dangerous is because it has this positive two charge, which causes it to become highly ionizing, and due to its high mass. So combined with the very high mass and this positive charge, it is highly ionizing inside the body. What could that do? That could cause cell mutation, and it could kill you, or it could lead to cancer and then kill you. Um, um, and this will continue to release radiation. So this polonium source will continue to release alpha up until it becomes stable, which could be millions of years, or you excrete it through the body and out. But sometimes this gets into your cells and you can't excrete it out. So you end up with radio radioactive poisoning and radiation sickness, and that um, ultimately leads to death. Part C, a sample of polonium left for 414 days. Um, The mass afterwards of the polonium was 1.45 times 10 to the minus 4 grams. The half life of polonium is 138 days. So, what we're going to look at is 414 days. How many half lives fit in the 414 days? So, we divide one by the other. We find that 3 half lives fit in this time. So, what does that mean? It means that if we've ended up with 1.45 times 10 to the minus 4 grams, one half life before this, it was double. Okay, so we know there's 3 half lives in total. So one half life ago, this mass was double what it was. So 0.000290 grams. Then another half life before, it was double that, so 0.00058 was left, and one half life previous to that, you had this many grams of radioactive polonium, and over time it has decreased. Over time, it has decreased and to 1.545 after for 3 half lives. So one half life, 2 half lives, and then third half life ending up there. So this was the original mass of the radioactive polonium 3 half lives before.